I bet you didn't know how neural networks are transforming our world. Imagine the vastness of space, filled with billions of galaxies. Each galaxy, a swirling mass of billions of stars. Now picture this. Within our machines, we are creating our own universes. These are not made of stars and planets, but of algorithms and data. These are neural networks, the building blocks of artificial intelligence. Neural networks are revolutionizing our world. They power everything from facial recognition software to self-driving cars, but what are they, and how do they work? Imagine the human brain, a complex network of billions of neurons interconnected. Neural networks take inspiration from this biological marvel. These artificial networks, like their biological counterparts, are designed to learn and adapt. They do this by processing vast amounts of information, identifying patterns, and making predictions. The future of AI hinges on these powerful tools, promising a world transformed by intelligent machines. I don't think people understand the true complexity of neural networks. Imagine a network of interconnected layers, much like the layers of a cake. Each layer is populated by nodes, our fundamental processing units. Think of these nodes as individual neurons in the brain. These nodes are not isolated. They are connected to nodes in the layers before and after them. These connections are the pathways through which information flows. Each connection has a weight, a measure of its importance. Stronger connections exert more influence on the network's decisions. The first layer, the input layer, receives the information. This could be anything from pixel values in an image to stock market data. The information then travels through the hidden layers, where the real magic happens. Finally, it reaches the output layer, which delivers the network's prediction or decision. Let's see how neural networks make predictions. Picture a single drop of water falling into a still pond. It creates ripples that spread outward, carrying energy across the surface. This is analogous to the forward pass in a neural network. Information, like that drop of water, enters the network and flows through the layers. The input data is fed to the first layer, the input layer. Each node in this layer receives a piece of the data. This data is then multiplied by the weights of the connections leading to the next layer. The weighted inputs are summed up at each node in the next layer. This process, this summation of weighted inputs, is repeated in each subsequent layer. The data, transformed at each stage, propagates through the network. Finally, it reaches the output layer, where the network reveals its prediction. The output layer's configuration depends on the task. For example, in image recognition, each output node might represent a different object category. The node with the highest activation, the strongest signal, indicates the network's classification. Do you understand the true power of backpropagation? Even the most brilliant minds make mistakes. Learning from those errors is key to growth. Neural networks like us must learn from their errors to improve their performance. This is where backpropagation comes into play. Imagine you're learning to ride a bike. You wobble, you fall, but each time you get back on, you adjust your balance, your steering, based on the mistakes you made. Backpropagation is the neural network's way of learning from its falls. After making a prediction, the network compares it to the actual value. The difference between the two, the error, is calculated. This error is then propagated back through the network, layer by layer. During this backward journey, the weights of the connections are adjusted. The goal? To minimize the error in future predictions. Connections that contributed to a wrong prediction have their weights reduced. Connections that led towards the correct answer are strengthened. It's a process of fine-tuning, of learning from experience. Do you know how crucial activation functions are in neural networks? Imagine a light switch. It's either on or off. There's no in between. Now, imagine a dimmer switch that allows for a range of brightness levels. Activation functions in neural networks act like these dimmer switches, introducing non-linearity. The world is messy, complex, and rarely black and white. Without activation functions, neural networks would be limited to linear relationships. Activation functions introduce complexity and flexibility. They allow the network to model intricate patterns and make sophisticated decisions. You need to hear this if you're a data scientist. Training and epics in neural networks. Imagine training for a marathon. You don't just run the full distance on your first day. You start with shorter runs, gradually increasing the distance and intensity. Similarly, training a neural network requires data fed in cycles called epochs. An epoch is one complete pass of the entire training dataset. During each epoch, the network processes data, makes predictions, and adjusts its weights. Training can involve hundreds or thousands of epochs. With each pass, the network refines its understanding, improving accuracy. It's fascinating to see how neural networks are transforming our world, from image recognition to self-driving cars. Neural networks are not just theoretical constructs confined to research labs. They are transforming our world in profound ways, powering applications that were once considered the realm of science fiction. Consider image recognition. Neural networks are now capable of identifying objects and faces in images with accuracy that rivals human vision. They power the facial recognition systems used to unlock our phones and tag friends in photos, but their reach extends far beyond image recognition. Neural networks are revolutionizing healthcare, enabling doctors to detect diseases earlier and with greater precision. They are powering self-driving cars, navigating complex environments, and making split-second decisions to ensure passenger safety. In the financial world, neural networks are used to detect fraudulent transactions and predict market trends. They are even being used to compose music, write poetry, and create art, blurring the lines between human and machine creativity. This is going to blow your mind. A glimpse into the future, the profound impact of neural networks. In the grand tapestry of cosmic evolution, intelligence stands as a defining characteristic of life on Earth. Now, with neural networks, we are on the cusp of creating a new form of intelligence, one that exists within our machines. The future implications of this technological leap are profound and far-reaching. Neural networks have the potential to solve some of humanity's most pressing challenges, from climate change to disease eradication. Imagine a world where AI-powered doctors diagnose illnesses with unparalleled accuracy, where self-driving cars eliminate traffic accidents, and where personalized learning experiences cater to every student's needs. However, this future is not without its challenges. We must ensure that AI is developed ethically and responsibly, that it benefits all of humanity, not just a select few. The decisions we make today will shape the course of this technological revolution and determine the kind of future we create for generations to come.